Here I'd like to provide an example concerning the analysis of uncertainties associated to debris flow risk assessment in mountain areas. This is an example from the autonomous province of Bolzano, where check dams have been built in a staircase-like fashion along this mountain stream. And during an extreme event, practically all those structures toppled down as a domino effect, if you want. And this makes again clear that the reliability of the protection system plays a relevant role in determining the overall behavior of a certain dominant process. In this case, probably a perfect functioning of the protection system without this rather devastating toppling event would have influenced the overall sediment transport rates and the overall sediment availability. Perhaps, let's say, preventing from upgrading, let's say, a debris flow process that produced several damages at the alluvial fan. So the consideration of disturbances in general is an indispensable requirement if debris flow phenomena are analyzed. It's quite useful to introduce a scenario topology in order to distinguish between the different types of scenarios. One suggestion that is used throughout the academic history, if you want, of scenario analysis is the suggestion by Ducott and Dubben. It's a rather old suggestion, but it's a clear suggestion, and I appreciate their effort to structure from a topological perspective the different types of scenarios. In this figure, first of all, you see three axes: a vertical axis, a horizontal axis, and an inclined axis. Each of those axes relates, let's say, to a certain dominant feature of the scenario. For example, if we focus our attention on the vertical axis, there is the cause-effect relation inbuilt. For example, on one pole, on the upper pole, we may identify so-called exploratory scenarios. That means that effects are deduced given a certain specific set of causes. On the lower pole, there are the so-called anticipatory scenarios that somehow try to offer explanations of possible causes given a certain set of effects. We will then see in more detail different examples. On the horizontal axis, there is represented the tension between normative and descriptive scenarios. That means between the fact that we might include our values in the scenario building process. This would give rise to the construction of normative scenarios, and if we somehow are value neutral or objective, if you want, we will produce descriptive scenarios. So the normative scenarios incorporate values of person using scenarios or of stakeholders producing scenarios of a desirable state. The descriptive scenarios instead produce possible occurrences irrespective of the desirability. Let's say, using the Latin term ceteris paribus, we do not include changing values. We assume, let's say, that the human actor is not influencing to a relevant extent the outcomes of the scenarios. On the inclined axis, we distinguish, with respect to the time dimension, we distinguish so-called trend scenarios, that are scenarios that somehow unfold throughout a certain interval of time. For example, if we imagine to produce scenarios of temperature increase due to certain emission scenarios, for example, we are portraying in diagram fashion the increase in temperature along a certain amount of, along a certain range of time, and so what we see is the trend, is the overall behavior of the portrayed variable with respect to time. On the other end, on the other pole, we have the so-called cross-sectional or peripheral scenarios that somehow portray, describe how the world looks like in a certain specific moment of the future. So imagine that we want to somehow predict the level of employment in 2030. We have overall the world, let's say on the whole planet, we may produce a map with different colors that somehow represent different levels of employment with respect to a certain moment in time, for example, the year 2030. So let's go a bit into details. Let's take the vertical axis first. The vertical axis, as we already mentioned, is referring to the causal nature of a scenario. So at one pole, exploratory scenarios are situated, where effects are projected given a certain initial set of causes. At the opposite pole, anticipatory scenarios are located. These anticipatory scenarios offer explanations of possible causes given an initial set of effects. So, reflecting about mountain stream processes, an example of an exploratory scenario is the determination of the liquid and solid discharge at the downstream end of a reach. For example, in this reach, there are also certain consolidation structures located, given certain boundary conditions at the upstream boundary, given certain liquid and solid discharges entering the system. So this is a so-called exploratory scenarios where effects are projected given a certain set of initial causes. So trying to be more clear about these exploratory scenarios. So here you have a picture that is somehow explaining what I already mentioned. Imagine to have a certain mountain stream reach with an inflow node, with an outflow node, and imagining to take into account a certain inflow process. For example, from other courses at Boku University, you know that the four dominant processes are debris flows, hyperconcentrated flows, or debris floods, bed load transport processes, or liquid discharge processes, let's say, without significant sediment transport rates. Moreover, as we mentioned in the first part of our video lecture, we have also to take into account the wood material transport that might be low, middle, or high. So this is a way to describe the dominant inflow processes. Then we have to take into consideration with respect to our spatial system, to our mountain stream reach, the so-called initial conditions. There are certain initial conditions with respect to sediment availability, to wood availability within the system, within the mountain stream reach. These are the initial conditions, how the reach looks like before, let's say, the occurrence of a certain event. And we have to take into account, given a certain inflow process, if you want, detected at the inflow node, what might happen in terms of material exchanges, either in a longitudinal direction, but also in a lateral direction. For example, the hill slopes might interact with the stream processes. Let's say if there is a certain hill slope undercutting, there might be a sediment delivery to the channel due to landslides. And so we have to take into account of the fluxes in terms of sediment, solid material, water, and wood in, let's say, the longitudinal and transversal direction. And as a result of these dynamics along the time trajectories, we will measure, or we will recognize a certain dominant process at the outflow node, which can be the same or might differ from the dominant process at the inflow node, depending on what happened the same amount of time within the stream system. So if, for example, relevant deposition took place, debris flow process might change to a debris flood process, or to hyperconcentrated flow at the outflow node. And also if there is relevant entrapment of wood material within the considered stream segment, probably also the wood material transport might change from high volumes to lower volumes. So determining exploratory scenarios means exactly this, means exactly describing what might happen if we know that a certain dominant process flow process is somehow delivering water, solid material, wood to a system, and if we know as well the initial conditions of the system in terms of sediment availability, water availability, and wood availability, with the knowledge of the boundary conditions and the initial conditions, try to establish what might happen, for example, at the outflow node. So this is well represents the exercise of determining a sort of exploratory scenarios. Let's deal with the so-called anticipatory scenarios. In this picture, you see how, let's say, the stream, a particular stream in Chile looks like after a lahar event, lahar flow event. You might appreciate the partially burnt vegetation and the large amount of wood material lying in the active channel. Starting from, let's say, a picture like this, we might interfere the possible causes that led to this final state, if you want. In principle, the features indicate that a lahar process is responsible for shaping the channel this way. Moreover, if we look to the vegetation, obviously we might infer that vegetation was severely damaged to the lahar flow as well, and this is a particular feature that is not that evident, or that is not that remarkable with debris flows. So in principle, this particular feature, this particular characteristic of the end state enables us to identify a set of causes, in this case a dominant process that is particular of the regions we are analyzing. In this case, we are at the Rio Blanco, near to the Chaitén volcano, and in 2008 there was a major volcano eruption and with major pyroclastic flows along the hill slopes, and after that hydrological events, extreme rainfall events, triggered Lahar flows along the main